Okay, today we're going to look at Chapter 5. We're looking at network and server attacks. So we'll look at some different types of networking-based attacks and look at how servers are attacked as well. A couple types of attacks we're going to look at. First was the networking. While you have several attacks that can be used against a network, they're going to be broken down into groups: interception or poison attacks. Some of these are going to be designed just to intercept the network communications. Okay, so we have like the man-in-the-middle attack, the man-in-the-browser attack, the replay attack. So we're going to look at each one of these. So we'll start off with the man-in-the-middle attacks. What this does is it intercepts the legitimate communication by forging a fictitious response to the sender. So we see here we got these two computers are sending and receiving data. Now, what happens is when you got a man in the middle sitting here that intercepts that data and reads that data, changes the data, they're able to access data they're not supposed to have access to. So we're looking at this one. So Bob sends out to send me your public key, and he sent it to Alice. Well, sitting in the middle of this is this person here. So in this case, they're able to intercept the message, and instead of sending Bob and Alice's key, he's intercepting Alice's key, her public key, and he's also intercepting the public key from Bob. Or he's sending Bob his public key. So now he's got access to any of the encryption information, so that the information is different that he's sending to each one of them. A man-in-the-browser attack intercepts communication between parties to steal or manipulate the data. This occurs in a browser, between the browser and the underlying computer. And normally it's going to have some kind of Trojan infection. It's going to affect the computer, and it's going to put some kind of extension in the browser configuration. So when the browser is launched, that extension is going to be activated. It's going to wait for a specific web page that the user enters. So it's going to look for things like your account numbers, your passwords, things of that nature. And when the user clicks submit, that extension is going to capture that, and it's going to send it on to the attacker, and maybe modify some of the data. Some advantages of the man-in-the-browser attack is that it is maybe difficult for it to be found. It's got a Trojan browser extension. It's going to have the malicious code installed. It might remain dormant for months until it's triggered by them going to that targeted website. And you see the last one is that it resides exclusively within the web browser, making it difficult for a standard anti-malware software to detect it. Replay attacks, where the attacker makes a copy of the transmission before sending it out to the original recipient. And what it does, it allows them to use that copy at a later time. So it's like they're copying your login credentials. Your information is still being sent, but it's sitting there and they're grabbing that information and holding on to it so they can use it at a later time. Some methods to prevent these. Both sides can negotiate and create random keys. A random key that can be valid for a limited period or a specific purpose, or use time steps in all messages, and reject any message that falls outside a normal window of time. All right, when we talk about poisoning, poisoning is the act of introducing a substance that harms or destroys. When we look at this as far as our networking attacks, we got three types of attacks here that's going to inject poison. We have an ARP poison, a DNS poison, and privilege escalation. Okay, ARP poison. ARP is our address resolution protocol. What that does, it says that the IP address for a device is known, but the MAC address is not. The sending computer sends an ARP packet to determine the MAC address. The MAC addresses are stored in ARP cache for future reference, and all computers that hear the ARP reply with a cache also cache the data. The ARP poisoning relies on MAC spoofing. All right, so it's imitating another computer by changing the MAC address. So attacks for ARP poisoning is steal data. Description is an attacker can substitute her own MAC address and steal data intended for another device. Prevent internet access. So you, once again, substitute an invalid MAC address for the network gateway so that no users can access external networks. So it can be used to really shut down the network from having communications with the outside. Man in the middle, where the man in the middle device can be set to receive all communications by substituting that MAC address. So using these, if you're attacked with this, you may think you're sending it to a legit recipient, the person that you're trying to send this information to. Okay, and they're changing the MAC address, so it's rerouting it to that person, to the attacker. A denial of service attack. It's where a valid IP address of the target can be substituted with an invalid MAC address, and it causes all traffic designated for the target to fail. Okay, so you're taking that IP address that basically it's like a street address. Let's say that we're in an office building, and the office building is 112 College Street. And inside there, you have an office mailbox that has different office numbers. And the mail comes in, and it goes to that office mailbox, and it's sorted and goes to the correct place. The denial of service is let's say my office on this campus is A225. So let's say that they set up a fake mailbox. All right, so the mail is still coming into this building, but they've got a mailbox somewhere else set up. So my mail is going to that other mailbox and not into my correct box. So there, I'm not getting my mail. I'm not getting access to my network. So I've been denied that service, which is what the attack like this does. Okay, so it sets up the invalid MAC address. All traffic's going to that spelling. Same with the mail. If the mail was coming here and it was going to a fake address, it's going to get returned. Okay, so I'm not getting access to it. So anything that's coming to me or through my computer, I would not have access to it. DNS poisoning. The domain name system is the current basis for name resolutions for IP address. So we look, for example, if we type in on this 127.0.0.1, okay, it's going to pull up our local host. All of our websites are going to have a DNS. The example for Google here, when we type in google.com, we can also type in 74.125.47.99. Okay, the DNS takes that Google and it reads it as the DNS number. What the DNS poison does, it substitutes the DNS address to redirect the computer to another device. Now we have two locations for this. You have your local host table and an external DNS server. So what this does, if you type in google.com and you've been attacked by this poison, it may take you to AT&T.net. Now, normally they're going to take you to somewhere that's going to be set up to look exactly like where you want to go. So if you're going to Capital One to pay your credit card bill, you type in Capital One and you've been subject to a DNS poisoning, then you're going to a site that looks exactly like Capital One because they're out to get your information, your login information. So the example here, we have our attacker's computer. We have a good user, and we have the attacker's DNS server, which is ns.evil.net. So what this computer is going at, it's typing in, what is the address for good.net? We see good.net is going to be 192.168.1.1. The attacker computer is looking for evils.net's address. Doesn't seem to give us to us on this list. So it's going to the valid DNS server. It's going over to the evil.net's DNS server, the attacker's DNS server. It's sending the evil.net back, and then it's sending that. It will be sent to the good user site. So they're not, anytime they try to access these sites, it's going to their server, and it's going to be redirected to, let's say, evil.net. All right, privilege escalation. We've talked about access rights, giving people only the rights they need to do their jobs. Privilege of least, principle of least privilege. So what this does is it escalates people's privileges. So we look at here, we see that access rights are privileged to access hardware and software resources that are granted to users. Once again, we want to make sure that we only give people the rights that they need, nothing more. With a privilege escalation, it exploits a software vulnerability to gain access to resources that users normally would be restricted from accessing. And we got two types of privilege escalation. You have a lower privilege user, accesses functions restricted to higher privilege users. This will sometimes be called the vertical privilege. And then you also have the horizontal privilege escalation. It's where a user with restricted privileges access different restricted functions of a similar user. All right, server attacks. We're going to look at a few of these. We'll look at denial of service, web server application attacks, hijacking, overflow attacks, advertising attacks, exploiting browser vulnerabilities. And what a server attack does, what a compromised server, it allows the threat actor, allows the bad guys with privileged contents, or it provides an opening for attacking on any device that accesses that server. A denial of service attack, it's a deliberate attempt to prevent authorized users from accessing a system by overwhelming it with requests. Most of them are going to be the distributed denial of service, which uses hundreds or thousands of devices flooding the server with requests. All right, so it sends out a request. The attacker computer will send out a request to the network. And it says, I want to connect. And it waits for an acknowledgement request. So the server sends one back and says, okay, where do you want to go? Well, that's when it's waiting on that attacker computer to send another request. If it doesn't, it just hangs up that transmission. So if you get these flooding in, and eventually it just makes it to where the network cannot access any more requests, cannot handle anything else. It just bogs it down and shuts it down. A couple of these attacks, a Smurf attack. It's where an attacker broadcasts a network request to all the computers on the network but it changes the address from where the request came from. So it's called IP spoofing. What this does, it appears that the victim's computer is asking for the response from all computers on the network. The computers send a response to the victim's computer, and it overwhelms it. DNS amplification attack floods a victim by redirecting valid responses to it. Uses publicly accessible and open DNS server to flood a system with DNS response traffic. The sync flood attack takes advantage of procedures for initiating a session, which one I just was talking about. So in this, the attacker sends a sync segment to an IP packet to the server, an IP packet to the server. The attacker modifies the source address of each packet so the computer addresses do not exist or cannot be reached. All right, so we see our attacker computer here sends a sync segments and IP packets to the server with a modified source address. So in this case, it's sending out the replies, and it's sitting there waiting for a reply from A, which doesn't exist, B doesn't exist, C doesn't exist. So it's sending out all these replies, these acknowledgement replies, saying, "Okay, I'm listening. What do you want to do?" And there's no response. So it eventually just shuts down because the server can't handle any more traffic coming through. All right, a zero-day attack. That's an attack that exploits a previously unknown vulnerabilities. It's called zero-day because victims don't have time to prepare to defend against it. Traditional network security devices can block traditional network attacks, but cannot always block web application attacks because many security devices ignore the contents of HTTP traffic. And we'll look at some different web application attacks target the input from users. And they're going to be grouped into two categories: a cross-site attack or injection attack. So look at this. This is the web server application infrastructure. You have your client, which would be the end user. They send the HTTP traffic to the web server, and it's going to be distributed to wherever it's supposed to go, whether it's app servers and then to the database server. A cross-site scripting attack. What this does is where the attacker, they exploit the vulnerabilities that some web applications have that accepts user input without validating it before presenting it back to the users. So the victim injects the website. The victim visits the injected website. Malicious code is sent to the victim's browser. Some of the cross-site scripting attacks are designed to steal information. Now, with this, an XSS attack requires a website meet two criteria. It accepts user input without validating it and uses the input in a response. So think of this as a form that you fill out that's not being validated. It's not checking, and just some simple validation that you may have on your form, maybe just a simple email address that validates it's an email address format, or so it's just taking that information and then giving it back to the user. So we see an example here. Let me go in here and zoom this in. So it's in this bookmark page. It's got our home, description, bookmark. So it says, "Thank you, Abby, for your submission." Click here, return to your bookmark page. Okay, so with this information was not validated. It just accepted the user input. So it took the input from the name and placed it in here. And then it's telling us to click this link. Now, in this attack, if we click that link, are we necessarily going back to where we wanted to? Oh, I mean, because it's been attacked. It's the browser has been compromised. So the attack uses the web browser's settings to impersonate that user. So now they have that information. If a user is currently authenticated on the website, it is tricked into loading another web page, as we saw with a click to go back to this bookmark. And the new page will inherit the identity and privileges of the victim to perform an undesired function on the attacker's behalf. All right, so we'll look at this here. All right, so step one, the attacker forges a fund transfer request from Bank A and embeds it into an email hyperlink. That email is being sent to the victim who's logged into Bank A's website. Victim clicks on the link. Request is sent to Bank A with the victim's valid credentials. So Bank A looks at it, and the Bank A is thinking, okay, this person authorized this. He requested this. So he's going to validate the request, the victim's credentials, and send the funds to the attacker. An injection attack, this is commonly going to be with the SQL injection. It introduces a new input to exploit a vulnerability. So like I said, this is going to be one of the most common is going to be your SQL injection. And what that does is it inserts a statement that's going to manipulate the SQL database, the database server. SQL stands for Structured Query Language. It's used to view and manipulate data stored in a relational database. So we'll look at the example here, like the forgotten password. The attacker enters a fictitious email address that included a single quotation as part of the data. All right, so this response lets the attacker know whether input is being validated. And then the attacker enters email field in SQL statement. Statement is then processed by the database. So we see here, this is some of the SQL language where it says select field list from table where field equals whatever or a, okay, so this is just information that's going to be put in there. So what that does, that's pulling the information from the database where you give us a select statement. So it's saying get this information from the database. So this is returning all user email addresses. And it will be displayed. So look here, we see that we've entered your username, email address on file. We see some SQL injection statements. All right, the whatever and email is null. It determines that the names of different fields in the database. Whatever and one equals select count. The asterisk from the tab name will display, discover the name of the table. The whatever or full name like Mia, okay, that's looking for specific users. Okay, so whatever they type in here, it's looking for anything that's like that. Drop table will erase the database table. And this here, this is going to update the email address. And it's going to update that, and it's going to email the password to the attacker's email account. We also have some hijacking. This is server attacks where the threat actors are commandeering a technology and then using it for an attack. So the common ones we have are session hijacking, URL hijacking, domain hijacking, and clickjacking. All right, session hijacking is where the attacker uses, they attempt to impersonate users by stealing or guessing session tokens, which is a random string assigned to an interaction between a user and a web application. These can be gained through the cross-site scripting, eavesdropping, or just guessing. URL hijacking is also called typo squatting. That's where the users are directed to a fake lookalike site. So we fill with ads where the attacker receives money from traffic generated to the site. The attackers purchase the domain name of the site that are spelled similar to the actual sites. And there are also registered domain names that are one bit different. This is called bit squatting. As an example here, this is something I can't read. So we got GOO.gl, and down here they got FOO.gl. So it's one bit difference that's changing the G to an F. Domain hijacking occurs when a domain pointer that links to a domain name to a specific web server is changed by the attacker. All right, so when a domain is hijacked, the attackers will gain access to the domain, their control panel, and redirects the registered domain to a different physical web server. Clickjacking is hijacking a mouse click. It's where the user is tricked into clicking a link that is other than what it appears to be. And this is usually going to rely on the attackers using a 0-pixel iframe, which the iframe is going to be short for inline frame. It's an HTML element that's going to allow for embedded other HTML documents to reside inside the main document. 0-pixel iframe is going to be virtually invisible to your eye, to the naked eye. So for example, if I placed a 0-pixel iframe, and I could have it this entire screen. Okay, so you wouldn't see it. It could just be one big button that says click here. And so when you think you're clicking on the next button, you're actually clicking on my giant button. Overflow attacks are designed to overflow areas of memory with instructions for the attacker. We got two types of overflow attacks. You got buffer overflow attacks and integer overflow attacks. All right, buffer overflow attacks, these occur when a process attempts to store data in a RAM beyond the boundaries of a fixed length storage buffer. So extra data overflows into adjacent memory locations. What this does, it allows the attacker to overflow the buffer with new addresses pointing to the attacker's malware code. Hold on a minute, my mouse pointers went crazy. All right. So we have here our normal process. You have our program instructions, buffer storing integer data, buffer storing character data, and the return address pointer. So we look at a buffer overload. We still have our program instructions and the buffer storing integer data. And the character data, the malware has been pushed in here. So it fills an overflow buffer and a new pointer. So it's going to point it back to the malware instead of going back to where the program instructions are. Integer overflow, that's where the result of arithmetic operations exceeds the maximum size of the integer type used to store it. So we look at the integer overflow attack. That's where the attacker changes the value of the variable to something outside the range that the programmer had intended by using an integer overflow. Now, this type of attack can be used in the following situations. The attacker could use the integer overflow attack to create a buffer overflow situation. The programmer calculates the total cost of items purchased, would use the number of units sold times the cost per unit. If an integer overflow were introduced, it could result in a negative value and resulting negative total cost. Also, a large positive value in a bank transfer could be wrapped around by an integer overflow attack to become a negative value, and it can be used to reverse the flow of money. If you go to the store and you use your ATM card, money's coming out of your account. If this is introduced, every time you use your ATM card, it could be taking money out of the store and sending it back to your account, which would be nice, but highly illegal. All right, advertising attacks. We have malvertising and ad fraud. All right, so the threat actors use third-party advertising networks to distribute malware to unsuspecting users who visit a well-known site. This is known as the malvertising or poison ad attack. So an ad contains the malware, redirects the visitor who receives it to the attacker's web page that then downloads either Trojans or ransomware onto the user's computer. Preventing this is difficult. Website operators are unaware of the type of ads being displayed. Users have a false sense of security going to a mainstream website, and turning off ads that support plugins such as Adobe Flash often disrupt the user's web experience. Ad fraud is where they manipulate pre-roll ads to earn ad revenue that is directed back to them. So in this, they've created a robo browser called a meth bot. It spoofs all necessary interactive needed to initiate, carry out, and complete ad auctions. We also have browser vulnerabilities. So we have some vulnerabilities that are in browsers such as extensions, plugins, and add-ons. Scripting code, it adds dynamic content to your page. Web pages are developed in HTML. All right, now the current language is HTML5. Okay, for the most part, that's just a pretty static page. Okay, so that just gives you pretty much a website that's pretty static. And if you want to learn more about HTML, you go to the W3 schools. But let's look at HTML. Okay, so this is just a language. So when I click try it myself, and we'll run this. This is my results. All right, so just simple code here. It's just giving me text. What scripting does, it allows dynamic content. JavaScript's going to be your most popular one. So these are instructions that are embedded inside the HTML documents. There are security concerns with JavaScript. You can have a malicious JavaScript code that's ran. It can be captured and remotely transmit user information without their authorization. All right, extensions they expand the normal capabilities of your web browser. These are something that's for a specific web page, and most of these are going to be written in JavaScript. And they're going to be browser dependent. Now, here it says an extension that works with Google Chrome will not function in Microsoft Edge. Microsoft Edge is currently revamping itself to start using the Chrome engine. So it's going to be trying to be more like Chrome, just because people never switched. You know, when they come out with Windows 10 and they put out Microsoft Edge, they expected everybody to switch over. Hardly anybody did. They just used Microsoft Edge to download Google Chrome. So they're trying to change it to where it's more compatible with sites that are built towards Chrome and the functionality of Chrome. All right, plugins add new functionality to web browsers. Allows users to do things like play music, view videos, display special graphical images. With plugins, that single plugin can be used on multiple sites. So one common plugin is Java. And Java allows people to create a separate program called a Java applet. And you see here the most widely used plugins for web browsers are Java, Adobe Flash Player, Apple QuickTime, Adobe Acrobat Reader. Flash Player is going away. So we see an example of the plugins. We have a web server, it's got HTML document. In here, it's going to import the Java applet, and the user is getting the HTML document, the Java applet. It's going to be downloaded to their computer. Now, if that plugged in is attacked or compromised, it's going to be downloaded to this user's computer as well, to their browser. Add-ons, these are things that can be used to increase the functionality of your web browser as well. They can be used to create additional web browser buttons, toolbars, change browser menus, look for other open tabs in the same browser. Now, we do have, like I said, we have risk with these, so extension plugins, add-ons, there is a movement to kind of minimize these. Some web browsers will not allow them to work. They'll block the plugins. In HTML5, it's standardized sound and video format. So things like Adobe Flash Player are no longer needed in this. You know, years ago, YouTube was a Flash Player based site. All the videos were uploaded. They were Flash Player. You had to have Flash Player. Now HTML has developed tags that allow the functionality of videos and sound directly into the browser. And as we see here, look at the video. So we see the animation here, the video playing. And we'll look at the code here. So they've got a video tag, and they've set the width, which is the width of the player. They got our source files located in here. Now, if these don't work for some reason, let's say our browser doesn't support the video tag, this is going to be displayed. And then a link is put in here as well. So we no longer have to use Flash Player to use videos in our websites. All right, so we've talked about the add-ons. I'm not going to go back through this. As we've discussed, the extensions, the plugins, and add-ons. All right, so that ends up chapter 5. So we've looked at different types of network attacks, different types of browser attacks. We've looked at SQL injection attacks, DNS, denial of service attacks, cross scripting. Looked at websites, attacks, and so forth.